So whenever you feel comfortable, you can start. You start when you start. Okay.
Does it work? I have a camera also if it doesn't.
Oh, that's a good idea, but no, so far it's working, Mike.
Hi everyone, my name is Mike. I'm a PhD student in electrical engineering, McGill University. Today I'd like to talk about the procedure of designing a control system. Before I present the steps, I'd like to give you a flavor why we need control systems. For example, to keep the temperature of this room fixed, we need air conditioner to control the temperature. Or for an unmanned airplane, we need a controller to guide our airplane in different situations without the pilot. For understanding the main important point of control, you can assume humans as a system. We are a system and the brain of us are controller. Because, for example, if there is something in front of me, I can see it by my eyes, and my eyes are sensors, and my brain is controller, which tells my body to change my direction. And this is the way that we control our activity. Control system can be used in any kind of system that you can imagine. It can be engineering system, economical system, or biological systems. Here you can see the main steps of designing a control system. The first step that is very important for control system is the study the system and model it. By studying the system, it means that we should know the system before we start, because it's the main important and it's the basis of other steps. For example, if you want to model a society, a population of a society, for example, the population of world, we want to answer to questions like how many children they can have, how many of those children can survive, and who are their main enemies, and blah, 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 these kind of questions. And then we can know the answers of these questions. After studying the system, we want to model it. By modeling, we mean to have a physical rules and mathematical notation for our system. It can be a system of differential or difference equations. After the first step, we go to the second one. That is, analyze the model and choose controller. By analyzing, we want to have the solution of our model. It can be the solution of differential equations. For example, we can model the position and velocity of a satellite in Earth's orbit. Or we can have the solution of the temperature of a room, and we can find the temperature after 5 minutes, or 1 day, or 2 days, or something. And then, at this stage, we realize that whether we need a controller to have a better response or not. And here, we should choose between different kind of controllers that we can have in different systems. For example, we don't want to pay $100,000 just to control the water level of a toilet. It's too expensive. And the last step is simulation the model and running a real system. After these two steps, we just want, because we are not sure about our system and the controller, we just want to simulate the model in a real, on a computer to find the solution and understanding whether it's gonna work or not. If it doesn't work, we should repeat the previous steps again, and for example the modeling, and find another controller But if it works, we can run in a real system. For example, for controlling the speed of a car, we can make it a real car and test it in different situations, on a windy weather, on a snowy weather, and in different roads, to check if it really works or not. To sum up, I've discussed the main steps of designing a control system for general kind of systems. As I mentioned, it can be any kind of system: engineering, biological, economical. And it is worth noting that being a good control designer, you should have a basic knowledge in mathematical notations and also be a well-experienced engineer. Thank you for your attention.